Good afternoon to all of you. Am I audible to everyone? Students, just let me know. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. So it has become quite late, but not a problem. Okay. So my screen is visible to everyone.
Yes, ma'am.
Okay. So here you can see that we will discuss three, you can say three properties like saponification value or saponification number, iodine value, and acid value for a given sample. So that sample may be for fat or oil. So we will see that how we can find out all these three values and what are the significance of all the three saponification, iodine and acid value for any given sample. Okay. Here on the screen you can see some examples of common fatty acids. Now why I am showing, because in the next slide we will use these fatty acids with the glycerol to give you the esters. They will become fat or oil. So commonly we use lauric acid. The formula is given on the right side of the screen. Then we have palmitic acid, also known as hexadecanoic acid, with C15. Then stearic, where we have C17. Then
Is
various.
this that soap formation process?
Yes, definitely it is related with the soap formation process because it is saponification. Very true. So, okay. Now, the fatty acids can be of two types, saturated and unsaturated. So, unsaturated means there is no double bond. Saturated means where we have double bond, right? In the basic terms. So, these are the examples of unsaturated fatty acids like oleic acid, it is found in olive oil, then linoleic acid found in corn oil. I'm also sharing the sources just because here we are not able to access the sample, but when you will be performing this in the laboratory, okay, so there you will be given a sample of any oil or fat. So that sample may be from the olive oil, corn oil, vegetable oil, butter, ghee, fish oil. Okay, so from that we can also find out that it is unsaturated, saturated, or what kind of fatty acid is present. So we can find out all, I mean, this much of information from three things: saponification value, iodine value, and acid value. Now, this is the structure of the fatty acid, how it looks like. You have seen in the first slide the formula C11, okay, C15, C17. So when it becomes triglycerol, it looks like this. more precisely, this on the screen you can see this is the condensation synthesis. Okay, a condensation process you can see here. Here the 3H, they are coming out with the oxygen to give you 3H2O. Okay, and this fatty acid, it will condensate with the glycerol to give you the fat. So that is why we call this as an condensation synthesis. The two are condensed together to give you fat. And during the procedure, water molecule is coming out. So it is hydrolysis. Water is breaking down. Now, if we look upon various property of the fat and oil, so there may be various properties. Okay, but briefly, we will only focus upon acid value, saponification, iodine. For detailed analysis, peroxide value, phospholipids, unsaponifiable matter, impurities, and other physical properties like transparency, color, odor, taste, relative density, refractive index, smoke point, melting point, freezing point, everything is determined. So, in simple way, we will first of all define what is saponification value of an oil or fat. अगर हमें किसी कोई भी सैंपल दिया है फैट या ऑयल का या लिपिड का और हमसे कहते हैं कि इसका सेपोनिफिकेशन वैल्यू निकालो, तो सेपोनिफिकेशन वैल्यू से क्या मतलब हो रहा है यहाँ पे? सो इट मींस कि जो भी सैंपल आपको दिया है उसके अंदर जब हम पोटेशियम हाइड्रोक्साइड डालेंगे तो वो अल्कली है, वो एसिड को न्यूट्रलाइज करेगा, तो आपको न्यूट्रलाइज करेगा, सो उसको फैटी एसिड जितने भी अंदर प्रेजेंट है उसको न्यूट्रलाइज करने के लिए कितना मिलीग्राम्स ऑफ पोटेशियम हाइड्रोक्साइड रिक्वायर्ड है, दैट इज द सेपोनिफिकेशन वैल्यू. लेकिन यहाँ पर एक कंडीशन है. कंडीशन क्या है कि जो भी आंसर आपका आए वो तभी आपको निकालना है जब सैंपल आपका 1 ग्राम हो. यानी हर समय हमेशा सैंपल आपका 1 ग्राम होना चाहिए. तो सपोनिफिकेशन को हम ऐसे भी कह सकते हैं कि इट इज द वैल्यू और इट इज द नंबर ऑफ milligrams of KOH required to neutralize the free fatty acids and to saponify the ester present in 1 gram of the sample substance. अब इससे पता क्या क्या चलता है? तो इससे ये पता चलता है कि जो सैंपल हमें दिया है फैटी ऑयल का उसमें कितने ग्लिसराइड्स प्रेजेंट है. ठीक है, बेसिक जो इंफॉर्मेशन मिलता है इट इज अबाउट द ग्लिसराइड्स. देन on reflexing with alkali, glyceryl esters are hydrolyzed. उसके अंदर जो glyceryl ester है उसका हाइड्रोलिसिस हो जाएगा और हाइड्रोलिसिस होने के बाद जो लंबा सा ग्रुप है एल्काइल, जो लंबा चेन है वो पोटेशियम सॉल्ट के साथ कंबाइन हो जाएगा. ठीक है, सो thus here we refer the saponification as to the hydrolysis of an ester when the reflux condensation is carried out in the alkaline solution. So this is your glycerol. जब आपको सैंपल गिवन होगा तो सैंपल देख के तो आप बता नहीं सकते हो कि इसमें कितना ग्लिसरॉल है. ओके, सो दिस इज योर ग्लिसरॉल and this is your long chain saturated fatty acid. So here for example we have taken palmitic acid. Okay, so this is saturated, we are producing a saturated fat. So after this addition we will have triglyceride और triester saturated fat. 3 एस्टर है इसके अंदर. ठीक है, so this is triester saturated fat triglyceride plus 3H2O. So this is the formation of the fatty acid. इसको आप इस तरीके से भी प्रेजेंट कर सकते हो, ये ज्यादा क्लियर है. ये आपका ग्लिसरॉल है, दिस इज योर 3 फैटी एसिड R1 R2 R3 आर योर अल्काइल चेन. यहाँ से हम एक एक H ले रहे हैं और यहाँ से OH. so it will release H2O. So we will get here 3H2O and triglyceride. Now we will come towards the principle. What is the principle of determining? So जो भी ऑयल्स और फैट्स होते हैं, दे आर नथिंग बट दे आर एस्टर्स ऑफ द ग्लिसरॉल, और उसके अंदर क्या होता है, इट इज कंबाइंड विद द ऑर्गेनिक एसिड, फैटी एसिड, जिसका मॉलिक्यूलर वेट बहुत ही हाई होता है, राइट? सो व्हाट वी विल डू, वी विल परफॉर्म a sort of titration. Okay, so here the properties of oils, fats, it will vary as per the degree of unsaturation, average molecular weight, acidity from hydrolysis, acid value, peroxide value, ester value, iodine value, saponification value. Okay, so we need to check the test, we need to check the property, which is very much important to fix the identity of specific sample, specific oil for specific fat. जैसे अगर मैंने कहा कि ये वेजिटेबल ऑयल है, तो वो मुझे कैसे पता चलेगा? तो उसका कुछ प्रॉपर्टीज होगा कि जिसका वैल्यू वही आएगा, जैसे एसिड वैल्यू, सपोनिफिकेशन वैल्यू। इसलिए ये बेसिक प्रॉपर्टीज है जिसको हम फाइंड आउट करेंगे यहाँ पे। ओके, सो दीज प्रॉपर्टीज हेल्प्स अस इन कंपेयरिंग द कंपोजिशन ऑफ वेरियस फैट्स एंड ऑयल्स टुगेदर and helps us to differentiate them, helps us to identify. So that is why these properties are of higher importance to be determined. तो ये प्रॉपर्टी हमारा प्रिंसिपल हो गया। अब हम यहाँ पर सपोनिफिकेशन वैल्यू स्टडी कर रहे हैं। ओके, सो व्हाट वी विल डू, ओके, सो we will take known amount of sample. Why known? Because we have to take 1 gram of the sample, and that sample has to be refluxed with the excess amount of standard alcoholic potash solution. Okay, now what will happen when we will perform this reflux process? The amount of the sample is known, and the amount of alcoholic potash solution will also be known to us. It will be taken in excess amount. तो क्या होगा जब हम इसको मिक्स करेंगे, रिफ्लेक्स करेंगे ज्यादा देर तक, तो क्या होगा? सोप आपका बनना चाहिए ना। अब आपका जो KOH है उसमें से पोटेशियम सॉल्ट जो है आपका फैटी एसिड में जो ग्रुप है अल्काइल, उसके साथ मिलकर के लॉन्ग अल्काइल चेन बनाएगा ऑफ पोटेशियम. So that is why we call this process as formation of soap, that is saponification. तो लेकिन सारा का सारा अल्कोहलिक पोटैश तो यूज नहीं होगा क्योंकि हमने तो एक्सेस में लिया है. इट मींस कुछ पोर्शन जो है अल्कली का, इट विल रिमेन अनयूज्ड, और जो अनयूज्ड अंदर बचेगा उसको हम टाइट्रेट करेंगे अगेंस्ट द स्टैंडर्ड एसिड. सो नोन अमाउंट हमें पता है, उसमें से कुछ यूटिलाइज हो जाएगा, कुछ बचेगा, जो बचेगा उसको हम टाइट्रेट करेंगे और ब्लैंक में से सब्ट्रैक्ट करेंगे नोन अमाउंट में से. तो व्हाट वी आर डूइंग बैक टाइट्रेशन. आर यू गेटिंग मी?
Yes, ma'am.
Okay, you can also refer this term in Vogel. Now this is a fat stearin. We are refluxing it with alkali potash. So what we are getting? Glycerol and potassium stearate. This process will occur after the reflux. So some of the potassium, it is getting utilized here for saponification process, but some amount will remain unused. This is our oil or fat. This is the general equation. So after reflux, we will get glycerol and soap, that is long alkyl chain of potassium, K. If we are using sodium, then we will get detergent. Okay, so our detergent is the long alkyl chain of sodium salt. So this is the general process, and this is the specific for stearin fat. So this much portion is clear to everyone.
Yes, ma'am.
Now, this is the portion from your journal. Aim is given, principle we have discussed. Now, in procedure, we will accurately weight 1 gram of the sample. The sample may be fat or oil. We will take this in RBF round bottom flask. Then we will add 25 ml of 0.5 molar alcoholic potassium hydroxide. Then we will allow it to heat. Now see, this is the alcoholic KOH. Okay, that is why we will keep this under reflex condenser for 30 minutes. We cannot give direct heat. But simultaneously, what we will do, we will allow it to be under reflex condenser, and simultaneously on the other side we will perform blank titration. So in blank, we will only uh, take all the reagents except the sample. So that will also be kept for reflexing for 30 minutes. Why? Because we are ensuring the same condition, including time, including the treatment, that is heating by reflex condenser. At the end of this, we will remove both the condenser, we will cool them, and then we will titrate the solutions with the standard acid, that is 0.5 molar HCl. Now here we will, for this type of titration, we use phenolphthalein as an indicator. Now suppose for blank reading, I am getting YML of 0.5 normal HCl. For sample, if I am getting X, okay. So what will be the formula? Okay, so formula for this saponification value, it will be your blank VML minus test means Y minus X, okay, and it is multiplied by the uh, normality of the acid, that is 0.5, multiplied by the molecular weight of this KOH. Okay, so it is 56 grams per mole, and we will divide it by weight of the fat or oil which we have taken. So you have to consider it, though we are taking one, but practically that may be different value, that may be near to 1 or that may exceed 1 in terms of decimal. Okay, so like this we will calculate, and here it is coming out something like 45.92, right? So we will report it as the saponification value is 45.92 of 1 gram of oil and fat. So there is a specific range given. Okay, here we haven't mentioned the range, but there is some range. Like, what if the answer comes between 10 to 20? What if it exceeds above 20? What if it is between 40 to 50? So that number it determines the molecular mass of the fatty acid which is present in your sample. Okay, so according to the mass, what we are doing, we are subtracting the unused amount from the blank. It means we are calculating that how much alkali is utilized for saponification. So it directly indicates the molecular mass of the fatty acid. So molecular mass of the fatty acid, it can be determined by using by saponification number. So if low molecular mass, then high fatty acids are present. Okay, higher molecular mass, then lower fatty acids are present. Now we will go towards the next experiment, which is the determination of iodine value. So like saponification, now we would like to know what is iodine value. Okay, तो iodine value क्या है, वो भी एक नंबर है saponification की तरह. किसका नंबर है, तो वो नंबर है कि हमारा जो सैंपल है वो कितना अमाउंट ऑफ हेलोजन एब्जॉर्ब करता है, उसका नंबर है. पर यहाँ पर भी क्या कंडीशन है कि जो हेलोजन का अमाउंट है दैट शुड बी एक्सप्रेस्ड इन ग्राम्स, और जो सैंपल हम लेंगे दैट शुड बी अराउंड 100 grams ऑफ द फैट और ऑयल. So this iodine value, it is also known as iodine adsorption value or iodine number or iodine index. Now, uh, initially when we started this lecture, I mentioned that there are two types of fatty acids, saturated and unsaturated. Okay, so now you might correlate what is the utility of this iodine. So since it is in halogen, okay, so saturated fatty acids will not absorb it. Okay, they will not give this halogenation reaction here. But those which are unsaturated fatty acids, they will absorb it. And by their absorption process, we can determine that amount. So this becomes significant for us to determine the degree of unsaturation present in the fat. Okay, so we have to take our oil or fat sample solution, then we have to add iodine chloride or iodine in ethanol, and we can also add mercury chloride to speed up the reaction. Now, how we can prepare iodine monochloride? Okay, uh, we will see that part. Then, what is this iodine monochloride method? So, this iodine monochloride method, it is also known as Vege's method. Okay, there are various methods available, but this is the simplest method which can be performed in laboratory. But what we need this reagent. So we will see later on how we can prepare it, but before that we will look towards the principle. Okay, so here again we will take up the sample in carbon tetrachloride CCl4. It is reacted with an excess of iodine monochloride solution, which we call it as With solution. So the unsaturated fatty acid which is present in your sample, it will undergo halogenation reaction. Okay, and what will happen, there will be an addition of iodine atom to one carbon of the double bond. Okay, so this is the basic principle or chemistry which is going inside the reaction. Okay, this we cannot see while performing the practical, this we can only see in the lecture. Now, on completion of the reaction, when your reaction will be completed, what we will do that uh, some of the reagent will be utilized as per the presence of the degree of unsaturation, but the remaining iodine monochloride which is present inside the solution, it will be there. So what we will do, we will give potassium iodide. So it will react with it to liberate molecular iodine. Okay. So what we need after the reaction is completed, we will add potassium iodide. Okay. So this will lead to the liberation of iodine, molecular iodine. Now, now you know how to uh, determine the liberated iodine by the titration method by using sodium thiosulfate. I think this we discussed in our previous lecture also, where we can use starch as an indicator, and here we can add mercuric ions to fasten up the reaction. How? It can eliminate the interfering halogens. So in this figure, in this screen, on the screen, you can see that this is your unsaturated fatty acid sample, and we are adding iodine to it. So the halogenation is taking place to the carbon, which has double bonds. And this is the basic principle which we will be using to determine the iodine number. So 1 mole of double bond, it reacts with 1 mole of iodine, I2, molecular iodine. And so the iodine number is defined as the number of grams of iodine that reacts with 100 gram of fat. So the iodine is adsorbed here, so that we cannot see physically in the RBF, but we can see here. And this is the theory is basically assumption, but it is verified by the practical. So we will perform the titration to determine the theory. Okay. Now, how to prepare the WIDS reagent? Okay, so it is nothing but iodine monochloride. So to it is produced by combining the two halogens. The ratio should be 1:1 molar ratio, and your equation will be this. So this is molecular iodine plus chlorine gas will give you iodine monochloride. Okay, so chlorine gas is basically passed over the iodine crystals, and when we observe the brown vapor, then we can say that iodine monochloride is prepared. Okay, so these dark brown iodine monochloride liquid is then collected. Excess chlorine which is there in the sample, it again converts the monochloride, this monochloride, into iodine trichloride. But this reaction is reversible, so this won't be any problem. Now, this is the theoretical principle, that this is the general reaction where we are taking the excess with solution with our unsaturated fat. So halogenation is taking place, you can see, and some of the iodine monochloride will remain unutilized because we are taking in excess. Now, this remaining will further be reacted with potassium iodide, which will release this ion iodide. So they will combine to give you molecular iodine. Okay. Now, this liberated iodine can be determined by standard titration process, by using sodium thiosulfate. Okay. This is Na2S2O3. Okay. And here we will use starch as an indicator, which is added after some time, so that iodine is not adsorbed on its surface and which remains unreacted. Okay, because we want to count each and every molecular iodine which is present in the solution. So when after addition of the sodium thiosulfate, the solution will turn pale yellow. After that, add the starch. So when we will add starch in this, it will directly turn to blue because iodine is present. And when gradually we will titrate it with this sodium thiosulfate, what will happen? So we will get this iodide and released and starch, which is free. So again, this will turn to colorless from blue to colorless. So this is the procedure. Oil fat sample is taken in CCl4 to initiate the mixing because it would not be easy to mix the fat sample with the iodine monochloride solution. So that is why we are taking the solvent carbon tetrachloride, okay, with an excess of with solution. Then the unsaturated fatty acid, it will directly undergo halogenation reaction and there will be addition of the halogen iodine atom to one carbon of the double bond. But when the reaction is complete, there will be unutilized iodine monochloride, so which will be further reacted with potassium iodide to give the formation of iodine. And later, this liberated iodine will be evaluated by standard sodium thiosulfate titration using starch as an indicator. Now, what is the significance? What we can derive? Okay. So, by measuring the iodine value, we can measure the degree of unsaturation present in the oil. We can say how much it is healthy or unhealthy. Okay. What kind of fat or oil it is. It is also an useful parameter to understand the rancidity of oil. So, rancidity is something which we can say when we keep the fried item in the monsoon season for a longer time and they are allowed to interact with the atmospheric oxygen or moisture, they start getting different type of smell which we don't find uh, proper for eating. Okay, so we discard it. Now, since the here you can see higher the unsaturation, if higher unsaturation is there, it means there is greater possibility of the oil to get rancid. Then iodine number are also used to determine the, that to ensure that double bond is present there or not. So the higher the iodine number, the more number of degree of unsaturation is present. More C double bond C is present in the fat. If iodine number is between 0 to 70, we can say it is a fat. It belongs to fat sample. If the value exceeds to oil, it is, if it exceeds 70, it is an oil. Why I'm saying this? Suppose AMC people are taking any drive for food samples. Okay, now they someone is this Ambika Dalwara can claim that I am using uh, uh, fat. Okay, I am making it in butter, but if they will check if the value iodine value is exceeding 70, the MC people will find that he is claiming falsely. It is not butter, but it is oil. Okay, this is an example just to make you understand this whole thing. So the basic principle is the halogenation addition reaction. Then starch is used as an indicator for this reaction to determine the liberated iodine. The color change will be from purple color to colorless. Okay, so this is the, just a minute. Okay, Now, this is the portion from the journal. We have already discussed aim and principle. These are the solution. Now, since we are performing the determination of iodine, okay, so we will have to keep this with in the dark condition. Otherwise, it can go photo decomposition. So we will weight accurately about this much grams of sample in a conical flask. We will dissolve the fat in 10 ml carbon tetrachloride, and we will add then excess of with solution. So we are adding 25 ml. Similarly, we will prepare the blank, but here we will not use the fat or oil as an sample. Everything, every condition will remain identical. We will thoroughly mix and we will allow the sample to stand in the dark for 30 minutes. At the end of this time, we will add 20 ml potassium iodide. This is 10% solution, and we will add 100 ml distilled water. Okay. Then we will perform the titration of the liberated iodine by using 0.25 molar sodium thiosulfate. So like I said, we will add this till we will get pale yellow color. Then afterward, we will add 2-3 ml of starch indicator, and then we will continue the titration. So our color change will be from blue to colorless. Now let's go to the calculation part. So again, here we will find out the difference between the volume of sodium thiosulfate used in the blank and in the sample. So for blank, there will not be iodine. Okay. Uh, okay. For blank, there will be maximum iodine will be liberated here because there is no unsaturation. So iodine will not be, the halogen will not be used up here for the halogenation reaction. So this value will be higher. But for test, since there will be some unsaturation, so some of the iodine monochloride will be utilized here to liberate the iodine. But some will remain unused. So the unused will be determined by reacting it with potassium iodide to liberate the iodine. So this difference will be calculated. Then afterwards, we have to multiply it with the factor they have given 0.03175. Okay, so it is nothing but it is the molecular weight of your iodine multiplied by the normality of the sodium thiosulfate, which is used for the titration, and it is divided by 1000. So it is 126 multiplied by 0.25 because normality of sodium thiosulfate is 0.25 divided by 1000 ml. Okay, so this will come as 0.03175. Okay, now they are converting it to the percentage. So they have multiplied it with 100 divided by weight of the fat or oil. So whatever weight we have taken, we have to consider it here. So they have considered 0.33. So in the later, you can see here, after calculation, we are getting 6.7% of iodine value. Okay. So we will report it here that iodine value for 0.33 gram oil is 6.7. Now the last one, determination of acid value. So Acid value is, again, it is the number of milligram of potassium hydroxide used to neutralize the free fatty acid present in 1 gram of fat. So what we will do, we will perform the titration directly by KOH here, just to ensure that, just to determine that how much free fatty acid is present here. Okay, we are determining the presence of acid in the sample. So it is a relative measure of rancidity. If our sample is in the form of glyceryl ester, then it is okay. But if it is exposed to moisture or some kind of atmospheric reaction, then what will happen? Fatty acid will come out of it in the form of free. Okay, there will be presence of free fatty acid. So by titrating this free fatty acid with KOH, we can say that our sample is rancid or it is fit for using. Okay, so this value is also expressed as percentage of free fatty acid. Now the principle for this, it is determined again by directly titrating the sample in alcoholic medium against standard potassium hydroxide, or one may use sodium hydroxide solution. Okay. Now this value is very much important. It has an analytical importance that the the fatty acid which is liberated here, it may be due to the atmospheric reaction of the hydrolysis of the glycerides. So that may be due to some high temperature. If we will keep our sample in high temperature, if we keep the wafers packet open, so after some days it appears to be stale. So this is the reason. Then there may be some microbial growth which may cause the growth of the presence of lipolytic enzyme lipase. So that will also decompose or degrade your glyceride to free fatty acid. Okay. So this is the carboxylic acid in fat or oil. So this undergoes auto oxidation. Okay. And it appears, it appears as an hydroperoxide. Okay. So after this type of moisture auto oxidation or hydrolytic or oxidative reaction, the molecule, or you can say that the sample will turn out to give you unpleasant odor and smell. So this may be asked as a question. Okay, why does the wafer packet after opening for longer period appears to be unpleasant? Okay, then the samples which will have high iodine value, they shows that they have high degree of unsaturation. It means they are more, you can say they are uh, susceptible for this kind of reaction. They are more susceptible to the auto oxidation free due to free radical mechanism. Okay. Rancidity is natural process of decomposition of fat or oil. It may be either by hydrolysis or by oxidation. Okay. In both the cases, free fatty acid will be liberated out of the sample, and fatty acids, they give some unpleasant odor and smell or and taste. So the process of degradation converts fatty acid esters of oils into free fatty acids, and this give rise to unpleasant odor and taste in the food. These lipids degrade to the point of becoming either unpalatable or they may become unhealthy. Unhealthy in terms of what? So, unhealthy means I will share. First of all, rancidity can be of three types: oxidative, hydrolytic, microbial. Oxidative, which undergoes auto oxidation to atmosphere. So, polyunsaturated acids which are present, they are known as PUFA. You may have heard of about a MUFA PUFA present in the oil. Okay, intracyl glycerol. So they undergo auto oxidation by free radicals. Then The end product is your aldehyde epoxide and peroxide, due to which it becomes unpalatable to eat. Then second is your hydrolytic rancidity. This is caused due to hydrolysis or due to enzymatic oxidation. Lipolytic lipase, and how it occurs. So it occurs due to contamination of fat by lipase. So if we have opened the packet and it is exposed for longer time to some microbes, okay, so they may lead to the formation of diacyl and triacyl glycerol. Okay, so again the end product will be aldehyde epoxide and peroxide. Then we have microbial rancidity. So sometimes it may be caused directly due to the microbial outgrowth, or it may be caused due to the moisture. Okay, so bacteria, mold, yeast, they can use their enzyme to break down the uh, ester of this glycerols, and they will produce unwanted odor and flavors. Then moisture also promotes this type of microbial growth, but this can be prevented by sterilization. Now, what are the factors which cause rancidity? So, sometimes there may be the presence of catalysts like trace metal ions, inorganic salts, then temperature, then how much amount of unsaturation is present, then how longer the packet is exposed, then presence of light, it may undergo photochemical reaction, then presence of moisture. So, these are the factors which affect the rancidity. Then how does it affect, what are the terms? So it can lead us to deficiency like anemia, hair loss, dermatitis. It can cause kidney and heart disease. It can cause neurodegeneration. It may also cause cancer. So please be aware to eat such kind of packets during this monsoon season. And last but not the least, all fat oil have saponification value less than 1. Acid value must not exceed than zero point 0.6 milligrams for every grams of KOH. Now we will come back to our journal portion. We have discussed the principle. We will look towards the procedure. So here we will weigh about 2 to 2.5 gram of fat or oil in a conical flask. We will add around 50 ml of methanol to facilitate the titration, because this is fat. This is a different media in comparison to KOH, which is another different media. Okay, another different phase. So that is why we are using alcohol to facilitate this titration reaction. We will use here 5 to 6 drops of phenolphthalein indicator, and then we will warm the mixture for about 5 minutes, and then we will titrate it with zero point 0.1 molar KOH. Now, what will happen? You will initially, when you will add 1 drop of this KOH, okay, so there will not be excess of KOH. So, phenolphthalein will give colorless. But when the endpoint will reach, the there will be the exceeding amount of KOH in that solution, in that conical flask. So when this will become in excess by a single drop, na, the color of the phenolphthalein will change and pink color will persist throughout the reaction. Now let's move towards the calculation part quickly. Okay, so this is the molecular weight of your KOH we are using for titration. This is the volume which is obtained after titration. Then it is multiplied by the molarity of KOH used. So here it is, I think it is 0.1, and volume which we have obtained is 0.5 ml. Okay. And how much weight of the substance we have taken? So it is 2.56. So after calculation, it is found to be around 1.095. Okay. So we will report it as The acid value for the given sample of fat or oil is found to be around 1.095. I have already shared the link of all the three experiments in the comment box. You can save it. If you have any doubt, you can ask me. All are sleeping?
No, ma'am.
Okay, good to hear you. So then I will assume that everything is clear to you people.
Yes, ma'am.
Okay, okay. So fine, if everything is going well, then now please prepare yourself. You can refer the journal which is uploaded in the Teams file. You can download it from there. You can access the videos from the links which we have shared. Apart from it, there are various other videos also available. You can also refer them. And definitely, we are there. If you have any doubt, you can ask us. And now, please start preparing yourself for the internals and externals. So, with this, now we will stop here and end this meeting.